name is Charlie Nicklin. I'm the Chief Executive of I Agree, and I'd like to thank you all for joining our February lunchtime lecture. I'd like to welcome Richard Dolman of A R Demolition Ltd as our guest speaker today. Richard is Managing Director of the Nuneaton-based business who are leading demolition experts in the UK. Their work includes some very tricky inner city projects such as the Broad Marsh Centre at Nottingham and King's Cross Station in London, which we'll get to hear about shortly. So just before Richard starts, you're all currently muted. If you'd like to ask questions, please use the chat function at the bottom of the screen, and then at the end of the presentation, we'll unmute you so you can ask away. So with no further ado, over to you, Richard.
Yeah, thank you, Charlie. Thanks for that introduction. Much appreciated. Nice to meet you all. This is going to be a little bit of a learning curve for me. Two reasons. One, this is my first presentation online, and secondly, it's still mind-boggling really to think that I'm doing this all through a mobile phone. So there might be the occasional time that I may freeze for a second. If I do, just bear with me. But so I will get straight into my presentation. Let me just share my screen with you. Okay. Can I just, Charlie, can you just confirm, please, that I'm sharing the screen okay before I start? Just a thumbs up and be fine. Yeah, great, thank you. So yeah, thanks for inviting me along to your lunchtime lecture. I'm sure normally there's a nice lunch after this. I'll wait for that for another occasion. But yeah, thanks for having me. So let me just. There we go. Okay, so just a very small bit about myself. So A R Demolition was formed in 2007, and it's actually came off the back of I formed it myself. I'm not traditionally demolition is many generations old, businesses are, but I'm actually the first generation, and I started out. I left school with not a great deal behind me. I wasn't particularly good at school, and I did an apprenticeship restoring E-type Jags, believe it or not. And towards the end of my apprenticeship, I felt that there wasn't the best future there for me. Having had an appraisal, I always had good appraisals, and I asked my boss where I could go in his company, and he said, not far really, he'll just always be a mechanic. And I was a little bit deflated and thought, right, I'm going to do something different. And through talking to a friend of mine, I thought it'd be a great idea to buy a JCB backhoe loader, which I did at 20 years of age, and went on a 2-week course to learn how to drive one, and built myself up a round of going out and hire and doing hire work, and gradually that grew to a second machine. And a few years in, a good client of mine told me that he bought a fuel station and he needed it knocking down, and would I be interested in doing it? And I just thought, well, yeah, I can do that. I'll give it a crack. And I did it, and I enjoyed it, and I made a few quid, and I thought demolition is very interesting. So I learned a lot about demolition through watching, learning, reading, and thought I'm going to give it a go. And very gradually, I turned my plant hire groundwork business into a demolition business. And in 2007, I merged it with my cousin because the burden was getting too large for me, and we formed A R Demolition between us, and simply Andrew and Richard. And since then, I've become a member of the Institute of Demolition Engineers. I've sat on the Council of Management of Institute of Demolition Engineers. I'm currently the president of the Institute of Demolition Engineers, and I've been involved in developing a degree in demolition engineering and management. And I'm extremely proud to say that I found out I sat the degree, and I found out, yes, I passed it. So I'm very proud of you know what I've done with it. So we still see ourselves as a local family business with, you know, the core values that go with it, but then trying to also have all the professionalism that goes with the modern business today. And a big thing for me is actually doing things like this, you know, engaging with other sectors and engaging with communities, and I think it's very important. And one of the reasons I do it is I'm sure you suffer with the same issues of skills gaps. And, you know, I'm always trying to attract people into the demolition industry to say that it is, you know, there can be good careers, it's interesting, and ironically, you might not thank me for saying it, I find one of the best fields to get staff from is agriculture. And I find that people that have worked in agriculture have a fabulous work ethic, and it's more of a work ethic of where to get a job done rather than what time are we knocking off. And that's something that, you know, I've got quite a few guys that have come from agriculture to us, and they're by far the best, just through their work ethic. So enough about myself and AR. I've just brought some bits up that I researched, you know, machinery that I've come across, very old machinery, particularly the piece of the engine on the right, I believe, was actually being used in a demolition project. The piece of kit on tracks on the left, I'll be interested if someone can tell me what it actually is at the end of this presentation, because I can't actually work out myself what that bit of kit is. So if someone can hold on to that and let me know later, that would be great, or whether it is just a type of tractor for towing things. But I have a passion for steam, which, as I was explained some earlier, that I'm not sure whether it's a good thing being seen as the modern day Fred Dibner or a bad thing, because Fred Dibner's practices in demolition were very entertaining, but I couldn't say that they were the best practices. But steam engines were used a lot in demolition, and really interestingly, I actually used a steam engine in a project of ours in March 2020, last year, and I used it in a very high profile project in a quarry for Aggregate Industries. We got some sections of old conveyor framework to tow up a ramp, and it seemed to be the best kit for the job, and it worked incredibly well. So we actually, it was interesting when I mentioned to the client I wanted to bring a 100-year-old engine into a quarry, steam engine with a winch on it, but it worked well, and they were delighted. And I do have a bit of, if it's not broke, don't fix it, and if a bit of kit will do the job, then use it. I have to pick up on the wrecking ball, because the two most popular questions ever asked to me are, do I blow things up and do I use a wrecking ball? I've done 3 explosives jobs in my entire career, and I've never seen a wrecking ball work in my entire life, which I would love to see one work, and they're still used widely in America particularly, but I've never actually seen one work. So the wrecking ball is well and truly ingrained in our history books, but you won't see one used in the UK now. Just to pick up on AR's steam, so the top left-hand picture is my engine when it was before it was imported to the UK around 15 years ago. The bottom right-hand picture is it post-restoration but pre-paint. So I've restored that, and I've ran it for a couple of years in primer, and it's Corona's caused a bit of a delay in the restoration, but that's getting stripped down this September and be painted in the AR colours, and or mildly in the AR colours, more traditional colours, and it's something I'm particularly pleased with, and you know, hope to use it on 1 or 2 of our projects. So about our techniques and how we consider our techniques and what we do, and there's various types of demolition. So there's the word demolition, where we demolish a structure. We get more involved in deconstruction, so reverse construction, take it apart. Quite often we're asked to take a structure down from somewhere, but with as little impact or disruption to the surrounding community as possible. So almost like a magic trick, we want you to get rid of that structure, but we don't want any interference to anybody while you do it. And then decommissioning. So the site I'm actually sat on as we speak was a former precious metals refinery in London, and as big a part of the demolition was decommissioning a lot, nearly 60 tanks on site with different chemicals and nasties in, and we had to clean every tank and every inch of pipework associated with the tank. So our job now is as big as decommissioning as it is demolition. And the techniques we use, I've mentioned explosives, but very rare. For me, explosives is absolute last resort. It's very disruptive. There's a lot of planning involved, and it's still quite unpredictable. What we call remote high reach demolition. So that's where we use large machines. We term it as remote, as in we're working a long way from the workplace, but it's not remote control. And then remote demolition is true remote, using true remote control machinery. And then we have what we call top down. So this might be a multi-story tower block where we'll wrap it in scaffold, and we will literally just take off one floor at a time, gradually reducing the structure from within the scaffold and bringing the scaffold down with the structure. And from the outside, you just wouldn't see it happening. All you'd see is a gradually reducing scaffold. Hydro demolition, where we use high pressure water to sometimes remove concrete, and still you'd be surprised at how much hand demolition work happens, where we really do carefully take things apart. So the key considerations we have is we try to liaise with as many stakeholders right from the beginning. So anybody that's involved in the project, whether it's the client, the surrounding public, anybody that might be involved is critical to engaging with those as early as possible. We have somebody to coordinate all of that planning, and then we have to look at things simple as a footpath closure or a road closure. You know, we can need 3 or 4 months sometimes to apply for a footpath or a road before we actually get that closure. And then a big one is services. So if you were demolishing a structure and there's a large gas main, a large electric main, we have to think about, do we need to divert it? Do we need to protect it? Or as simple as before we demolish a structure, we have to disconnect the services, which can be challenging itself. And then asbestos is one of the big things that we have to survey for. So by law, before you start any work on any structure, whether it's refurbishment or demolition, you have to have an asbestos survey done, even if it was built for after we stop using asbestos, because there's still a likelihood that something may have got in there. You know, perhaps something was stored in a builder's yard, and the builder thought, oh, we'll just put that panel in there. So we still have to have what we call an R&D survey done, so a refurbishment and demolition survey. Asbestos is a funny one, because a lot of people run scared of asbestos, but it controlled correctly, it's not expensive to deal with, and it's not expensive to dispose of. And particularly, in the agricultural world, we do lots of asbestos cement sheds, which is the lowest risk asbestos of the lot, really, and the training is fairly simple to deal with that. And then the disposal is fairly straightforward as well. And then once we get to site or towards the site, the operational planning, so making sure that we're compliant with all the local laws, rules, regulations, thinking about what method we're going to bring a structure down. A key one for me is exclusion zones. People quite often don't put enough attention into an exclusion zone. How big an exclusion zone can we have? A demolition contractor will want an exclusion zone that's enormous, but that's often not practical because of surrounding roads or other buildings, many things. So then we have to think of what we can do to bring that exclusion zone down, and that's when we get into the world of what we call temporary works. And temporary works can be propping or protection. Many things are classed as temporary works, which is where we build a temporary structure to allow us to bring down a structure, or just one prop is classed as temporary works. And in our world now, we can't just put a prop in. We have to design the prop. We have to get that design checked and passed off before we can do that, because if we don't, we're technically breaking the law. We then have to think about logistics. We use a lot of large plant machinery, and we have to think about how we're getting that into difficult locations like city centres. There can be weight restrictions or just size restrictions. And then a big one is welfare. The welfare of the staff on sites. We put a lot of things in place now. The site I'm on at the moment, we built an accommodation village for 20 people to live in on site, and because of the corona situation, we tripled the amount of canteens and tripled the amount of toilets, one-way systems in place, hand sanitizers in place, automated devices to check temperature, which would alert the site management. And the client was even good enough to fund a system which we put in the sewerage network. which was monitoring all of our guys' sewerage, and we believe we got a 3-day head start on any other symptoms shown for the virus. So you're starting to see already that demolition's probably not quite what it's perceived to be. And then environmental controls, we are continuously monitoring for dust, noise, vibration, and we have systems where that's all being logged, recorded, alerted if we go over certain thresholds. So that's a huge thing. And then controlling things if we have got a dust problem or a noise problem or a vibration problem. And then social values, something that we get heavily involved in. So we'll perhaps hire a local community centre and ask the surrounding public to come and talk to us, and we'll tell them what we're doing and talk them through the project. Or we'll get involved in a local charity. So the project I'm sat on now, we always get people that, oh, can I buy that door, or can I, sell me some bricks? And what we do is we sell those bits and pieces, and we always donate it to a local charity, something local to where the structure's going from, which is part of the social value things that we do. So the project I'm going to talk to you about is a very challenging project that we did in Nottingham. It was a multi-storey car park with underneath it a bus station, and there were many challenges thrown at us with this project. So this is an aerial shot that was taken during the demolition, and to just point out most of the constraints. So we've got a lot of cafes and restaurants around us. Exactly opposite was the Crown Court. To the west elevation was the Nottingham tram line. Between the tram line and us was the Nottingham Inner Ring Road. The area outlined in white is a 5-lane piece of road that between the car park and the Broadmarsh Shopping Centre. And that piece of road was actually a bridge. So it underneath it was shops, which were all kept open during the project. In the bottom right-hand corner of the car park itself, there were 4 shops and a Subway actually within the structure, and our brief was we got to keep every one of those shops and that Subway open for the entire duration of the demolition. So we had to bring 4 or 5 stories down to the top of these shops and onto 2 elevations of them. There was an overhead pedestrian bridge from the car park to the shopping centre. The shopping centre, as I've mentioned. On the east elevation, we've got solicitors' offices, another link bridge. Underneath the structure, there was a district heating main. And I should also point out as well, there was a BT fibre optic running through the structure. So we had to consider every one of these things before we even started work and plan how we were going to do the project. The people involved in the project, we got the client, which was Nottingham City Council. Were the operators of the shopping centre. They were very interested in what we were doing because we were working directly above them in some places, and the people that they'd leased shops to. And then there were several consultants involved in the project. And also the HSE took a very keen interest when they learned that we were knocking 4 stories of car park down directly above some shops with people doing their shopping in. So early doors, we built what we call a 3D phase animation. It's actually a 4D. So by 4D, we build a 3D model of the project, and then we animate it so we can show people how we're going to do the project before we even start. It's almost like a cartoon, but it's a fabulous way of showing how you're going to do something. Over several weekends, we put an exhibition in the shopping centre talking about how we were going to do it. We also put in there, we have a simulator of one of our demolition excavators that we actually use to training our operators on, but also we were letting the kids have a go on it, adults have a go on it. So we were attracting attention with the simulator, but then people were watching the animation and talking to us about the project, which was very successful. A local college was doing an engineering-based course called the Budding Brunels. We had them on site for a visit and taught them all through the demolition project. And all the way through the project, we had work experience students as well. with regarding planning and approvals, so we had to design the project. We then had to get road closures in place, footpath closures in place, think about how we were going to protect those shops, and we had a lot of structural engineering input into, you know, helping me design our method, basically put maths to what I was saying we were going to do. And the competencies, so in the world of demolition, we have various different stages of competence, right from a labourer to demolition operative to what we call a top man, which is incredibly politically incorrect now, but it is still the words that we use. And that's somebody that's a highly trained demolition operative that's working out on the site but not operating plant, and you know, working with the hands a lot, steering what the plant's perhaps doing. And then we have plant qualifications, supervisor, manager, and then memberships of the Institute of Demolition Engineers, which is something that I mentioned earlier. So these are just some shots of the 3D model that we built, where we talk about site establishment, so we could demonstrate to our client what we were going to put up in the way of welfare, parking, and then we superimpose onto this the phasing of the asbestos removal, what we call the soft strip, which there wasn't a lot of in the car park, but where we take out doors, door frames, anything that's not part of the main demolition. Then the structural demolition phasing, we talk through all of that. And interestingly, this, as you'll see soon, that the phasing of the demolition had a very large change. And that was through this. So these are the link bridges I was talking about. So the one that you can see that says looking for the perfect gift. So we calculated that bridge to weigh around 65 tons. Now, when the plan was to stand the crane right next to that bridge, connect the crane, maybe 2 cranes, cut the bridge, turn it slightly and lower it onto a low loader, and then road it out. And as I mentioned earlier, so where those cars are, that's all actually bridge section. There's people underneath there. And through our structural surveys, we established that the bridge wouldn't take the weight of the cranes. And the other thing we have to do, we have what we call the safety factor. If we think that bridge weighs 60 tons, 65 tons, by law, we have to allow to lift double that. So we had to allow to lift 130 tons, because we get to a point of no return. And when we get to the point of no return, if we've slung the bridge onto the crane and then we cut the bridge, we have to be absolutely confident that we've got our calculations right and the crane's got capacity in it, for obvious reasons. So when we found out we couldn't put the crane on the bridge, so the original proposed method, the top left, was how we were going to do it. We thought, right, that's not going to work. What can we do? So what we then did is the top right, we demolished 2/3 of the car park all the way back, and then we took a large middle section out, and then we parked one of the biggest mobile cranes in the country in there. And so we were lifting 60 tons at a radius of nearly 60 meters from the center of the crane. But the crane was now not mounted in the bridge, it was mounted in the footprint of the old car park. But before we could even get the crane to site, we had to prove the base of where the crane was going to sit. So we have to do lots of tests on the ground. Once we've got the information from the ground we then have to design a platform for the crane to sit on. So by the time we'd finished, we put down a meter deep of crushed hardcore for the crane to sit on. And we have to put that in layers, compact it, test it. And we have to guarantee that base is suitable for the crane. And I had to insure the crane for just under £8 million. And so not only are we we're having to satisfy our insurers that we're doing everything right to site the crane before we even connect the crane to the bridge. And then once we've gone through all this planning and we execute, so the bottom left-hand picture, you can see we've got one of the bridges suspended off the crane. It's not 100% clear, but the bottom right-hand picture, you can see the base of the crane in the bottom. Now, the crane came to us on 12 articulated lorries plus the crane base itself. and it took nearly a day to assemble. You can make out there, we're lifting one of the sections. We actually lifted it over the top of the car park, lowered it into the site, dropped it down and cut it up. And we did one on a Friday night and one on a Saturday night through the middle of the night. So there was probably 8 weeks of planning in for 2 nights of work. For anyone that's interested, I'm sure they are, the crane cost £25,000 a day in hire charges. So I was keen for it to go like clockwork, as you can well imagine. So then I mentioned about, we got this section that we were to do that was over the shop. So the illustration on the top right, the green floors are the ones that were coming out, apart from the very bottom one, which was the roof of the shops. And we had to come up with a method to get these floors off while keeping the shops open. So we demolished up to 2 sides and left this section, and then worked out a way to dismantle this. And because it was all concrete and steel, we came up with a process where we'd cut the floor into sections, lift the floor out in sections, and then lift all the beams out. So we had to work out exactly where the floors join the steels, and we would use diamond cutting equipment to cut those floors up. The way that worked, we'd do one section of floor at a time, and we worked with a system where we would have 2 gangs operating, 1 gang preparing, 1 gang lifting. So we got good utilization of a crane, and we just took that down floor by floor, 1 floor at a time, until we got to the top of the shops. And I'll come on to that a little bit more later. And again, I talked about temporary work. So even a hoarding around the outside of the site, by law, you can't just put a timber fence up anymore. We have to look into the local weather cycles that date back 2 or 3 decades. And then we have to design a fence that we think will be wind resistant for the duration of the project. And then once we've designed that fence and passed it off, we put that fence up, and we have to get an engineer to sign it off. So something as simple as putting a fence up now is not simple. And this is what we call temporary works. And a bit more temporary works. When we were demolishing the car park itself, we came up with this innovation that we call Big Blue. And if you look at this picture on the left, you can just see the traffic lanes which have got traffic in. And we were about 8 meters from that lane with the face of the car park. And that was the only exclusion zone we were allowed. So we needed something to protect those lanes. And a lot of contractors use scaffold, but I don't believe that scaffolds suffice to protect from flying debris or even a partial collapse. But they're not. It wouldn't be great for dust. So I came up with this device, which was a 45 feet tall structure with 2-inch timber face on it, and it was designed. It could take a partial collapse, and it could also obviously protect from flying debris. And then we came up with other techniques for dust control. You can just see on the left hand side, we've got what looks like a snowmaking machine, which is blowing atomized water at the demolition, and that became an incredibly effective piece of kit for controlling the dust. And that's mounted on a 19-meter Manitou telehandler, and we demolish one bay at a time. And then when we demolished a bay, we'd pick that entire frame up and move it to the left. Now, how that frame traditionally works is we put a large amount of ballast weight in the bottom, but we couldn't on this project because we're still sat on top of that bridge, and there was fear of the framework going through the bridge. So on the non-leading edge of the demolition, we'd actually tie it back to the structure, so that the structure was actually acting as a support for the frame. And it proved to be a very effective way of controlling debris and in the event of a partial collapse. A little bit more to talk on temporary work. Something I didn't mention was that the whole car park was clad in precast concrete panels. We had to get most of these off before we started the demolition. We came up with a method where we could get a lot of them with a crane, but most of them we had to do from the inside. And the top middle picture, we used a small skid steer. We mounted a hook mounted jib on it, which we had to have tested. and we drilled every single concrete panel and put a lifting eye in every panel. But in our world, you can't just drill it and put a lifting eye and connect a chain to it and lift the panel up and drag it into the car park. We'd have to put a lifting eye in, and the bottom middle picture, we'd do a pull test on every lifting eye to make sure it was going to take the weight of the panel before we could connect it, lift it, and bring it into the car park. And this is just a chart to show the different types of panels and the different lifting eye arrangements for each panel and the weights of each panel. So you can see some that we were lifting in were 3/4 of a ton, and where we had to be particularly careful. A lot of the reason the car park was coming down was the fixings of these panels were failing and the panels were becoming dislodged. So we wanted to get these off first because we couldn't have falling panels during the demolition project. There was just one elevation where we didn't take them off, whereas basically it didn't matter. If you come back, you can just see on the top left-hand picture there, the panels are still on the structure, and that was on an elevation where there were no services lower down, no bridge, nothing, so they could be brought down using traditional demolition techniques. I mentioned to you about, so these floors that we took down floor by floor, again, we have to think about safety of the workforce, and we had to come up with a platform that we could put under the working face of where we were working. So that's where we came up with Baby Blue, another innovation of ours, where we built these platforms which have got a handrail on. So whenever there was what we call an open edge where somebody could walk off, there was always a handrail. And then the other 50% of the frame would be sat underneath the panel that we're about to lift. So we'd sling a panel, well, we'd saw cut it, the panel, sling the panel to a crane, and then we'd lift the panel out. And as we lift the panel out, this device allowed there to be a false floor underneath. When we lifted the panel out 1 meter at a time, we'd move the frame back and go again. And we got, as I mentioned, we've got 2 of these working. And what it allowed us to do, coupled up with handrails that we put on top of the structure, we never ever once had an open edge. So there was never anywhere where anyone could walk off. And we'd always got every single panel supported before we cut it. The top section of this frame was on hydraulic rams. So every time we moved it, we'd just lift the frame up a few inches. So as it was almost supporting the panel that we're about to lift out. I mentioned to you about welfare. So the top 2 pictures are pictures of our actual welfare setups. And, you know, we take this seriously. It's where our guys have their breaks, have their lunch. Often, we quite often have a cleaner on site. If you look closely, the top right pick quite often put planters with flowers and things in to, you know, try and make it a little bit more homely and nice. And you know, these things are important. And then the bottom illustrations are just an illustration of how we intend to set our welfare up to show the client. Environmental controls during the project. So I've mentioned that we do various types of monitoring: dust, vibration, noise. We test for asbestos in the air just while we're doing asbestos removal. And then we produce graphs and charts at the end to show all the statistics of what we've had. We manage all of the waste. We sort everything out, and we don't just sort it out to metal, concrete, wood. We then sort the metal out into grades. We do different things with the concrete. We separate the waste. You know, when we do a project in general, we'll separate carpets, curtains, and everything that we can stream easier as individual products. We can generally recycle a lot better. And we're working towards this thing now, cradle to cradle strategies, because I'm very passionate about you know, we knock an older structure down and it's far easier to recycle than a modern structure, and that doesn't really make sense to me. And quite often an older structure's lasted a lot longer than a modern structure as well, and we need to be looking hard with clients and designers of new structures of what we're going to be doing with a structure at the end of its life. It's a really big deal, this is. And I mentioned about our dust machine, and this is actually the base of it. So you saw the head of it, but I wanted to pick up on this because you'll see on the front, as you traditionally know, a telehandler, that's a generator on the front, which the electric power runs the head of the machine, and then you can just see on the back there's water tanks, so it's independent. We fill the back with water. We have the generator at the front, and we just position this round site. The head on the top of the boom is remote control, and we can be very targeted where we're controlling the dust. I'm sorry, that should have actually turned to a video, but I appear to have failed with that. I'm sorry. So on completion, we leave the site neat and tidy. If you look closely at the picture, you can see a pile of crushed concrete on the right. We crushed that down to 40 mil down and certified it as what we know as type 1 for reuse in the next building project. And actually there's a new car park on there now, which is nearing completion. You can't really make it out, but the piece of structure directly in front of you, that is now the roof of the 4 shops that remained, with all the other structures taken off the top. Ironically, after we'd done it and completed it, and the main contractor's price to build the new car park, every single main contractor said, we're not warranting the new car park on top of the old bit of structure. And we then got instructed to return and demolish the bit that we'd saved, which was interesting. I mean, it was a good challenge to demolish down onto the top of 4 live shops, but then a little bit disappointing to knock them down at the end of it. We then produce a job completion file which has documentation which shows where we've got rid of every little bit of waste. It's important that we have a full document trail to say what's happened with all the waste. We sit with clients at the end of the project to do a lessons learned for them, and really importantly is we look for client feedback on how we could have done things a little bit better. I'm going to try, hopefully. Oh, no. Yeah, if we're taking any questions, I've got something where I can hopefully get the film I want to show you logged up. So yeah, in summary, demolition, it's a really exciting industry to be part of. We're always changing what we do, we're learning and working around changing environments. And I hope that you enjoyed a quick look at my world, and perhaps have a little better understanding of what we get. And thank you for your time. Any questions? So if I stop sharing my screen.
Okay.
Would you like me to go on mute now for a moment?
Yeah, it's fine. There's plenty of questions come through. I mean, that was absolutely fascinating, as most things are when you get to know some of the detail that goes behind it. If I just start the questions, there's an absolute immense amount of work seems to go on before you even start the job. How many people and how many weeks worth of work are there to get to a quotation stage? Because there's so many, I was going to say unknowns, but it's not unknowns because obviously people are experienced in the process. But how much sort of work goes involved before you start?
Depending on the size of a project of that scale, the tender period is probably only between 4 and 6 weeks, and you'd be amazed at the amount of information we don't get, and that's where demolition can be quite challenging, because when we lifted the bridges, it's actually dangerous if you've got what we call as-built information, because can you really rely on it? And the answer is no, you can't. So we start from a blank sheet of paper and working out how heavy is that, how we're going to do that, and that's where the difficult planning comes in. But so I employ 85 people. Just over a quarter of those people are all office based, so that gives you an idea of the back of house that's supporting what actually goes on when you finally come and take down a structure. I mean, one of the people, we have a permanent CAD engineer that's building these 3 and 4D models, so we can demonstrate to people what we're going to do before we even do it.
And do they tend to be fixed price quotations then, or is it lots of conditions? Because obviously you could quite easily price yourself out of a job if you cover everything.
Yeah, exactly. And more now, yeah, it's fixed price. There's a structure, give us your price, and you know, anything that comes up your way is your problem, which is challenging.
Yeah.
And that's what I actually just made my dissertation on, was fixed price contracting, because I don't think people quite understand what risks people are asking to be taken, and I don't think people fully understand where risk ultimately sits.
Yeah.
Which I could I could elaborate on that for hours, but I'm sure you don't want to be bored with that.
Okay, so I'll open the floor up some questions. So Brian Matthews has a question about asbestos. Brian, if you want to unmute yourself.
Sorry, I'm trying to find the unmute button. Yeah, no, fascinating insight into your industry here. Sort of from a personal point of view, and having seen asbestos being mined in Zimbabwe, and literally dust floating across the scenery towards nearby villages, and being horrified by it. How do you deal with asbestos in this country? You said it's not particularly dangerous if you deal with it in the right way. And well, thinking of things like roofing sheets, for example.
Yeah, so as I mentioned, roof sheets, asbestos cement, the asbestos content is very small. And how we often deal with roof sheets now is our industry has explored this and researched it and practiced it. So yeah, a lot of you will wince at what you hear, what I'm about to say. So the safest way for us to take an asbestos roof sheet building down is to shear the entire building down with the machine and drop it to the floor. And at that moment, people are like, my word, really? But there's a lot of control measures around that. So you need a good clean floor to work from. You need good dust suppression, things like monitoring the wind. Air monitoring is crucial, and how you clear it up is crucial. But we've established that it's safer by far to do it that way, rather than de-sheeting a structure. If you de-sheet a structure, you've instantly got people right at the coalface. And an absolute classic is when you bring a sheet down and you stack the sheets, people don't just put the sheet on top of another sheet. They put one end on and then push it across, which does a really effective job of removing any moss and things like that. But what that's doing is it's upsetting the surfaces of the sheet and releasing fibers. Or when you removing a roof sheet, you're releasing fibers. Whereas if you get a good damp atmosphere using the dust suppression equipment we have, and have air monitoring in place, and just shear it all to the ground, soak it all, and scrape it all up, and mechanically put it into the correct bins, we have pages and pages of data now to say that that's the most proven best technique. But if we then turn our attention to what we know as licensed asbestos, so pipe lagging, sprayed coatings, all the real nasties, we have to understand exactly what that is. And cutting a long story short, it's the complete opposite. So we build airtight enclosures, which we put a negative air pressure in, and they're continuously tested with smoke for leaks. And so you've got a sealed airtight cell, but you have what we call air movers, which are continuously sucking air out through a filtration system. And while they're sucking the air out, in theory, if there's any leaks, the leaks are all sucking inwards. So there's no way there can be any fiber release. And then when the guys go in there, the staff go in there, they wear special suits, special breathing apparatus, they carry out the removal, and then they transverse in and out of there through airlocks. And then when they come out, they have decontamination unit that they go through. And all of this is all done under license. And it's very difficult to get a license. And once you've got a license, it's very difficult to keep your license. You know, any slight breaches of law and things, and you lose your license. So I have guys that are trained in non-licensed removal, as I've just talked about, asbestos cement roof sheets, but then we subcontract in specialists to do the real nasty asbestos removal.
Okay.
I hope that's answered that one for you.
Thank you very much indeed. Most interesting. Cheers.
Yeah, but can I just caveat? Please do not just go and cut a shed down. I've just told you to do it. Get somebody in that's trained and qualified to do
that. David Clare, you got a question about costing?
Yeah, I think you've actually answered some of the question from Charlie's first question is how you go about doing it, because like that bridge there, did you, when that first costing you put in, did you actually cost it for the first method and then have to change the method, and assuming there's a big cost increase in that, or did you bake into the costing some sort of extra contingency there, or did you even have a chance to look at it beforehand before you put the costings in?
Yeah, that's a great question, because no, we costed it on our first method. We always do have or try and build in some contingent, but as we went to the second method, that was our hit. We had to take that. We had to take the pain for it. And I had got a client, if I'd have been really contractual, I probably could have got some more out of them, but I probably would have never worked for them again and upset them on the way. And it's all a bit of a balancing act, isn't it? You have to take the rough for the smooth. You have to take, you have to work out what could change. And unfortunately, we just ate right into our contingent on that and some, which is the nature of the beast.
Oh, thank you for that.
Okay, Mark Andrews has a question about surveying ground conditions.
Yeah, hello there. That's a really great presentation. Thank you very, very much. A question about how do you, the example of the crane is a really good example. How do you typically survey the sublayers on a construction and an industrial site? How do you know that they're not voids and poor soil conditions underneath?
Yeah, so your timing of that question is very, very poignant at the moment. And the reason being is I had a demolition rig drop through a basement on the 8th of January this year. And I talked about when before the call got busy is I'm big into lessons learned. The first thing I did with that was I built a presentation and I shared it in the industry. Look, this is what's happened to us. This is what we're doing about it, and all of our lessons learned, and it's still ongoing. I'm sharing that information, and what's come out the back of it now is we've built a hierarchy of what we do. I mean, we do have things in place, but something got missed in this instance. But our clients technically have a responsibility to inform us with surveys and information, but that rarely happens. And there's normally a line in a contract that says something, if you are deemed to encounter, allow for unknown basements and that type of thing. And so we've now built a hierarchy of, is the client information good enough? Yes, great, continue. No, well then we'll do a ground penetration radar. Are we satisfied with the ground penetration radar results? Yes, continue. No, okay, we'll now do some core holes. And we just keep going until we're satisfied. And we got some of these procedures in place, but they clearly weren't good enough. And in 25 years, that's the first time I've had an incident like that. It was quite scary, but it was, a good lesson learned, nobody hurt. And then actually our acid test is the machine itself. So, when you've exhausted everything else, put a breaker on the machine, put the attachment of the machine down on a slab, give the slab a good wallop and progress forward like that. And so, yeah, it's as much as we're experts, we still have incidents. But for me, the big deal is how we learn out of those incidents and make ourselves better.
Thank you very much. That's a great answer, and pleased the crew are all right. Good to hear.
Yeah. You don't need to research it too hard on the internet, and you'll find that machine, a picture of it inverted in a basement.
Yes, telehandler, was it?
No, it was a full 40-ton demolition rig on tracks.
Wow.
Yeah.
Alan Plum have a question about explosives.
I'm going to preface this first, Richard, and I don't want to frighten you, but I spent 35 years with HSE. But don't worry, you're amongst friends here. So my focus is particularly on the agricultural world. And you're clearly not of the Blaster Bates school. I remember going to a presentation by him when he was talking about blowing up tree stumps on farms. One was alongside a midden full of slurry, and his tagline was "There was a shower of shit all over Cheshire." But that's one thing I remember from that evening. But my question really was about why do you rarely use explosives? Is it out of choice, for self-preservation, or mechanical means appear to be more controllable, obviously? And is there a difference in cost?
Yeah, so I'm in a minority, as I don't see the HSE as the enemy. So you're okay with me. I like to work with the HSE. We do a lot with the HSE. We invite them to sites and do forums with them, and I often attend HSE offices in Crewe and do talks like this, so as to educate the HSE in a way. But now going back to your question, yeah, explosives. So to put explosives into perspective, explosives are used in demolition as the straw to break the camel's back, which immediately I'm uncomfortable with that, because what you do is you pre-weaken a structure right up until the point of it's ready to go, and then you use explosives to do the last bit. You can imagine the risks around that, and then it's quite disruptive when it does happen. When you do bring it down, you have to enforce a huge exclusion zone. So if that's in a city centre, if you could put a 300-metre exclusion zone around a structure, where you imagine the people you've got to evacuate, put somewhere else, and then when you've dropped it, has it done any damage to services, surrounding structures, the dust, the cleanup? It's massive. But then sometimes there's no alternative. So I did one at the back end of last year in a quarry. I demolished a 1,200 ton screen house, so a large set of aggregate hoppers with screeners on top. It was nearly a 30-metre tall structure. But I worked with a guy that's developed some explosives where we did zero pre-weakening, and these were cutting charges that cut steel up to 4 inches thick, and there was 2 types of charges we used, one to cut and one to kick, and they go off at microseconds apart, so that the cut will happen and cut a steel leg, sort of, a section at the bottom and the top 6 feet apart, and then the kick will go off just after and knock that section out. It's just like kicking a leg from under a chair, but you do it on every leg down one elevation, and it was very effective. But that was in a quarry, so the risk around it was minimal. But for me, yeah, I'm just not a fan of explosives demolition, because I think there's so many more methods you can pile up in front of it, and there's no real cost benefit either.
Yeah, just to follow up to that then, chimneys always seem to be the favourite for explosives, and they always make the news because they're spectacular.
Yeah.
I remember late 70s, the power station at Chelmsford was adjacent to the HSE office, and I came back one day to see the cooling tower just landed at an angle. I've got a photograph of me leaning against it, but and then you go to the other extreme. Didcot Power Station must send huge ramifications with multiple deaths through the industry. But yeah, so a chimney then, is that out for you? You don't adopt the Fred Dibner method?
No, I definitely won't adopt the Fred Dibner method of a chimney. I've done some chimneys and I used explosives, but again, in an ideal world, it'd be nice to get a high reach machine on them. Sometimes you can't, and sometimes there is no other method, and then you have to put it in place. In a big chimney, there's rarely another method. You can. I've seen chimneys brought down with a device where it starts at the top and works all the way down, just crunching it down. It's almost like a spider that sits on the chimney
Mhm.
and sort of reduces everything around its legs and then lowers its legs and goes again. But you've instantly got a lot of people working at height. So if you did a risk assessment, you'd probably say that's last resort if you've got nowhere to drop the chimney using explosives. But to touch on the Didcot thing, a bit of a theme I've talked about during this presentation is the huge disappointment on top of the obvious for me for Didcot is, and for those of you that don't know, so Didcot was a large power station that was being prepped for explosive demolition, and during the preparation it collapsed. And unfortunately, 4 people lost their life during that collapse. And the secondary bit of disappointment around that is it was the 5th anniversary of that, literally any day around now. And we still do not have one bit of information, nothing, no potential lessons learned, no this could have happened, that could have happened, or watch out. Everybody's in absolute lockdown just because of the pending legal cases. Now, talking to a guy in America, America has a policy to have any case like that shut down, buttoned up, finished in 18 months. Lessons learned, the whole lot. But here we are 5 years in with actually no end in sight, nothing. And I just don't see that as good enough.
I mean, you feel sorry for the families and everything as well, but as you said, to share lessons learned. I'll give the floor in a minute, Charlie. I'm just going to say there seems to be an opportunity there. I don't know how many more chimneys there are in the country to come down, but robotics might be a good solution for that one.
Yeah, absolutely. Yeah, the robotic machinery is astounding how good it is now.
Yeah, thank you.
Okay, we've probably got time for one more question. Martin Coulter, question about fuel storage sites.
Hi, yeah, I just queried, I work in a consultancy and we're dealing with fuel storage depots. So we go into old sites, maybe refurbish them. We come across old tanks that have stored heavy fuel oil or unleaded petrol. Have you ever worked in that sort of industry?
Yeah, so I mentioned this site that I'm on here where we decommissioned nearly 60 tanks with various different things in, but all sorts of acids and things, where we analyse what's in each tank and then how we're going to clean it out. But interestingly, fuel, particularly heavy oil, is one of the most challenging of the whole lot to deal with. And we deal with heavy oil a lot when we do projects in quarries, so bitumen tanks. So many times when a quarry shut down, it gets switched off on a Friday night and left with 60 tons of bitumen in a tank or more, and it all goes soft, hard, gloopy, what we're going to do with it. And we have people that we use where we basically manage to reheat it and get it out, and then do a clean down job within the tank before we take the tank apart. And there's a huge amount of planning and risk assessment around that. But yeah, whenever possible, we try and clean a tank out before we deal with it.
Okay, thank you.
I hope that helps.
Yeah.
I'll probably sneak one more question in. Jenny has a question about precious metals, and then we need to draw it to a close. Jenny, do you want to unmute? Or maybe not. She was basically asking a question about refining. Oh, you're saying sorry now. Are you there, Jenny? No. There was a question about precious metals, and I think really, when you're pulling things apart, how clean do you get the different materials that come out of the demolition project?
Yeah, so we work hard on not only the steel and things like that. We grade all that into various different grades: light iron, reinforcing bar, what we call shearing, which is somewhere in between light iron and constructional steel, and then we cut it to different sizes to get a better price. So that's just one side. Then we get in towards the non-ferrous, copper, aluminium are the basic ones. Things like copper tube and things like that, we we take it right back to individual components. So we cut all the brass fittings off, we cut all the clips off, we get it just back to copper tube. Cable, we strip cable back down to its format. But then we've gone another stage now, whereas we've got a piece of kit that we bought, a tiny device, just a gun that's sort of this size, handheld gun. It's a laser gun, and it analyzes metal for us. It was a large investment, and we use that, and it tells us what grade the copper is or what grade stainless steel is. And on this project here, this is the reason we bought it. We got a lot of tanks which were made of Inconel, and then it grades the Inconel. So we saw everything right out to the type of metal and then the grade of metal, and then we go to the marketplace to sell it. And with these things, it has an effect on how we actually price the job. So if we think there's a lot of metal in a job, the price comes down, and we can often end up in a world where we are paying the client to do the job, depending on what metal's in it. So, and I see metal as the root to all evil, second to drugs, because the amount of problems with theft and things like that, it's difficult to manage, but it's something that we've had to get smart with to work out what's the best to do with metal, and how to get rid of it. And just you made me think of one other thing with this refinery in Acton. It's only a small place, and they refined the really precious metals: gold, silver, rhodium, lots of weird metals that we've never heard of. And the lengths that we've had to go to with training our guys on this site, and they have to have skin prick tests to see if they've got what they call platinum, any of the PGM, platinum group metals in their blood, and if they've become sanitized, so it can break down their immune system to what that metal can do, and we'd have to take them off site. And we've been recovering things here that we would never dream of recovering. So we and the project team here whereas we'd take a carpet out and throw it into the bin, carpets were going from here to another refinery to be refined because there might be gold or silver dust within the carpet, or we were separating grout from floor tiles because platinum over the years could have soaked into the grout. And not only is it hazardous, but B, it got huge values. So the learning curve on this project for myself and the team was immense.
Okay, well, I mean, that was really interesting, really interesting. I'm so glad you saved a bit of time for questions, because there was lots of really good questions off the back of that. So thank you, Richard, for taking time out to present to that. Really interesting. I think you'll get lots of people requesting you doing that presentation in other areas, real insight into the industry for us, and certainly not something we hear much about. I think, demolition probably doesn't do it justice, really, does it, these days?
No, definitely not. And I'm really sorry the videos didn't work, but if you go onto YouTube and just put AR Demolition in, we've got a channel on there. There's loads of time lapses and great stuff like that you can look at.
Okay. Yeah, we'll do that, I'm sure. So before we close, thank you all for joining us today, and I hope you'll join us for our next lecture on the 16th of March, where Gareth Ellis from Cranfield University State, who's the Environmental and Energy Manager, is going to talk to us about how he's saving the environment and also saving the university money at the same time. So all that's left to say is thank you, everybody, for joining, and see you again next time. Bye-bye.